So thanks and welcome to our webinar. I'm Robert Shanafelt, a Senior Solutions Engineer at CircleCI, and I'm happy to be joined here by Michael Lanthier, a Partner Solutions Architect from Amazon Web Services. And we're excited to be offering this webinar on deploying ARM-based applications to AWS Graviton2 with CircleCI. We're going to be covering a couple of topics today, starting with an introduction to CircleCI and CI/CD, followed by an introduction to AWS Graviton2. Then we'll look at some of the details of using Graviton2 on CircleCI. During this session, feel free to drop your questions into the Zoom Q&A, and we'll have Sam and Eddie from CircleCI answering some questions as we go. We expect about 30 minutes for the presentation, with some time left over for questions. Okay, let's get started. CircleCI's mission is to give development teams the power to build and deliver software with speed and confidence. Our values revolve around this mission, which hasn't shifted much since the company was founded 10 years ago. At a glance, CircleCI is the largest shared CI/CD platform with over 2 million daily pipelines on AWS alone. And overall, we have over 1 million active developers at over 40,000 organizations. And we're helping these organizations with building, testing, and deploying software with speed and confidence. We've also been mentioned in the Forrester Cloud Native CI marketing as a leader, and also mentioned in the Deloitte Technology Fast 50. So CircleCI offers best-in-class CI/CD. And for those who could use a quick refresher, continuous integration and continuous deployment is a cyclical process where you continuously move changes from source to consumer. For example, your CI/CD system will watch for changes in your code base or other source. Then you have an automated process that will execute a set of build and testing workflows. And finally, when you're ready, you can deploy to production or any other environment. So in this example, you see we could be listening to a variety of sources of change, such as custom code, open source code, internal services, third-party services, or registries. And then CircleCI will take that, look at those changes, and kick off a workflow that can do building, testing, deployment, and release, or any combination of those. And those consumers could be end users, such as a production environment, or it could be other services like a microservices cluster. So let's see where CircleCI sits in the toolchain. We think CircleCI sits in what we call the orchestration bucket of your toolchain. The platform automates your customer pipeline from commit to deploy. What this means is that every time you commit code, CircleCI creates a build, then automatically runs your build in a clean container or virtual machine, allowing you to test every commit. Your team is then notified if a build fails, so issues can be fixed quickly. Passing builds are automatically deployed to various environments, so your product goes to market faster and unbroken. So in this example, you see the creation side is source control systems such as GitHub and Bitbucket. And CircleCI will be looking and listening to those commits. And when those commits happen, CircleCI can pull your code, do builds and tests, and finally release it to environments such as AWS, where you can run your production applications. CircleCI is a developer's first company. Developers choose us because we are the fastest cloud tool available, 70% faster than other players in the market. With our approach to CI/CD, you have many ways to improve your build performance, such as parallelizing jobs like tests, so that your team isn't waiting around for builds to finish. And so this is an example project we did a little comparison between a large Node.js project, and CircleCI completed that project build in under 5 minutes. And you can see that quite a few of the other players in the market took much longer. The thing to keep in mind is that speed isn't just important because it makes developers happy. That speed is what makes teams more productive, with an average of 63% reduction in build wait times. This increased speed translates to a significant savings by reducing developer costs. Compare $87 an hour to 36 cents an hour, and it's easy to see that it's less expensive to invest in the best-in-class CI/CD tools than to pay for lost developer time. Integrations and extensibility. CircleCI is highly flexible with the ability to handle common tasks such as build, code analysis, testing, artifact generation and notifications, etc., but also other workflows such as those shared by the community or the users within your organization. You can also integrate your existing toolchain to stay productive using our API and CLI. CircleCI webhooks and orbs are a convenient way to encapsulate and extend CircleCI functionality. Speaking of orbs, let's take a closer look at what is available to save you time. The CircleCI ecosystem includes a number of integrations with other types of orbs. Orbs are like a package manager for your CI/CD tasks. We have partner orbs that have created orbs for such things as testing and performance, code coverage, package registries, analytics, and release tools. And CircleCI provides a large number of certified and supported orbs. For example, for cloud providers such as AWS, or frameworks like Docker and Kubernetes, and also commonly used application frameworks and build tools like Gradle and Node.js. And finally, communication tools like Slack or Twilio. Finally, if those don't cover all of your use cases, you can write your own private orbs. This helps you reuse code and processes, helps you encapsulate your company workflows, or it could be used as a template for new projects for CI/CD projects. So now that we've taken a quick look at CircleCI, let's turn our attention to AWS Graviton2. So I'm happy to hand this over to Michael Lanthier of AWS to talk about Graviton2.
Awesome. Thank you, Robert. My name is Michael Lanthier. I'm a partner solution architect at Amazon Web Services, and we're here to talk a little bit about where these applications are going to be deployed and how Graviton2 instances running on ARM in the cloud can support your workloads. Right. Let's see if we can move on to the next slide. There we go. Okie dokie. So before we get into Graviton2 specifically, let's talk about how our customers are running in the cloud today. We at AWS are aiming to support a broad set of different workloads that our customers are aiming to run. And while we have many different ways to run on AWS, many of our customers are still using virtual machines and the Elastic Compute Cloud, EC2, to support their workloads. And to support the broad range of workloads that our customers do come to AWS with, we offer many different types of instances. These are instances to support your CPU-intensive workloads, instances to support your memory-intensive workloads, and burstable workloads and things like that. On top of that, we also offer a full set of different capabilities on top of these instances. We have different storage configurations, accelerated compute options, fast networking performance that all help enhance these instances that you're currently running on today. And this ultimately adds up to more than 400 different EC2 instances that customers can use to run their workloads on AWS and meet their business needs. Sorry, I'm having a hard time. Oh, there we go. Yeah, Robert, you may have to click through for me today. Thank you, thank you. And to support these instances, we have them running on a number of different processors. We've been working with Intel with their Xeon Scalable processors, which has enabled us to deliver large compute and high memory instances to our customers. Additionally, we've been working with AMD to use their EPYC processors as well, which are a powerful yet cost-effective option for x86-based workloads. And finally, we have our own custom-built silicon developed by AWS that we'll be talking about today, our Graviton processors. So let's go a little further into that. So what is Graviton and what is Graviton2? Graviton processors are processors built by AWS. They're built on the ARM architecture. And specifically, we have Graviton2 processors, which are running ARM Neoverse N1 cores. We took these 64-bit ARM cores and built silicon around them, custom designed and purpose-built them for the AWS cloud. The Graviton2 processor is the second generation of ARM processor that we have developed at AWS, with the first generation processor, the A1 instance type, being released previously. So why Graviton2? Why at AWS did we build our own processor? We at AWS have lots of knowledge of running large workloads and operating cloud infrastructure. We have a wide breadth of applications that we and our customers are running to support our businesses as well as theirs. And we've been able to build in targeted performance and cost optimization for our customers and for their cloud native workloads. Building our own processor has allowed us to innovate on behalf of our customer and really focus on the performance and cost benefits that our customers look for when running workloads on AWS. So how does this Graviton2 processor differ from our original first generation Graviton processor? So the Graviton2 processor has 64-bit ARM Neoverse N1 cores. It has about 30 billion transistors, and it's built using a 7 nanometer process. So what does this translate to? This means the Graviton2 processor has 7 times the performance of the first gen Graviton processor. It supports more cores, 4 times the compute cores, and it has 5 times faster the memory performance while also having twice the total amount of caching. This is really great performance improvements that we've seen. So let's look at how we're using these processors within our instance families. So as previously mentioned, our first generation Graviton had a single instance type. It was the A1 instance. With Graviton2, we've been able to offer many more. Our Graviton2 Power instances are designed to support general purpose workloads, your compute intensive workloads, and others. There's a broader spectrum of workloads that we aim to support. And on top of that, we also have features similar to other EC2 instance types, such as NVMe-based storage and bare metal options. And with all of this, we've been able to offer these instances with 40% better price to performance relative to comparable current generation x86-based instances, all while providing functionality similar to our other instance types. These instance types are currently generally available. They're available in 23 regions worldwide and are currently handling production customer workloads. On top of that, we also have a free trial running through the end of December for the T4G, which is our burstable instance type. So if you're interested in trying out Graviton2, that would be a great place to start with a T4G micro instance. So what is powering these Graviton2 based instances under the hood? First, they're all powered by, as we talked about, the custom Graviton2 processor, which offers really great performance. And additionally, our Graviton2 based instances are taking advantage of our Nitro system. The Nitro system has a couple of components. First is the Nitro security chip, which monitors hardware resources on the box. And second is the Nitro security card, which manages devices like Elastic Block Store for storage and Elastic Network adapters for networking interfaces. And this offloads all of that extra work and management onto the Nitro card. So the Graviton2 based processor does not have to deal with it. This is all tied together by the Nitro hypervisor, which is very lightweight and gets to take advantage of these optimizations brought on by the security chip in the Nitro card. All of these purpose-built and modular building blocks give Graviton2 based instances this great performance that we're seeing. And now that we've seen kind of the power of Graviton2, what it looks like under the hood, what does this mean for customers who are looking to run applications on these Graviton2 powered instances? So let's take a look at some benchmarks. First, let's specifically look at CPU performance. So here we've run the Spec CPU 2017 benchmark. This is an industry standard CPU intensive benchmark, and there's 2 components here. First is Spec Int, which runs integer reliant benchmarks, so compiling with GCC, route planning, Sudoku solvers, things like that. And then there's Spec FP, which looks at the floating point side, like physics simulations and ray tracing. Here we've run the benchmark concurrently across vCPUs on 2 comparable instance types. And what we've seen is Graviton2, looking at the spec scores, is 44% faster per vCPU than the comparable x86 based instances for the integer side of things, as well as 24% faster for the floating point side. But we also want to be able to look at more of applications that our customers are running in the cloud. So the next benchmark we see is going to look at a common use case that we see with many of our customers. So NGINX is a popular web server and load balancer, and here we're aiming to measure its performance as a load balancer. We have a load generator on the left-hand side, which is making requests, which are being load balanced through an NGINX instance to web servers behind it. The blue NGINX instance here was run either with an M5 x86 based instance or an M6G Graviton powered instance. And we were able to see a 24% increase in requests per second handled by NGINX running that M6G instance, the Graviton instance, over the comparable x86 instance. So the Graviton2 powered instance was able to load balance more requests than its x86 counterpart. And this performance increase was also done at a lower cost. Now that we've seen a common customer use case, let's take a look at another one while also looking at Graviton2's memory performance in a memory intensive application. So here, memcached is an in-memory key value store, which provides really fast data lookups. It's often used as a caching layer in front of a database to improve responsiveness. Here we tested an instance running memcached with 576 load generating connections from 3 other instances. And when we were running Graviton2, we were able to see 43% more throughput than when running it on a comparable x86 instance. But when running memcached and running these caching applications, we not only want to have high throughput, we're also worried about latency. We want to provide as low as the latency as we can. So when we measured latency for the Graviton instance and the x86 instance, we were able to see that M6G instance sees lower latency as well across the board. So not only is Graviton2 able to provide higher throughput, but at a given throughput, it's also able to provide lower latency than its x86 counterpart. So now that we've looked at performance in a couple of different applications, what does this mean for our customers who are running workloads using Graviton2? So first, these Graviton2 powered instances are the highest performing instances within their families. Customers are not going to be compromising on performance by moving to Graviton2. It may even be performing better. Next, we're also able to do this at a lower cost. This results in up to 40% better price performance than comparable instances. This adds up to Graviton2 based EC2 instances having the best price performance ratio within their families, leading to cost savings to our customers and ultimately a lower total cost of ownership for people running applications on Graviton2. So not only does Graviton2 have great price performance benefits, it also continues to have support of many of the other technologies that you're using today. If we're looking at operating systems, many operating systems that our customers are running today currently support Graviton2. Our own Amazon Linux 2 can be used to run workloads on Graviton, as well as Red Hat, SUSE, and Ubuntu. And we also have rich support of community operating systems as well. And the next thing that our customers also tend to look at is the container space, which Graviton and ARM has lots of support in. Many runtimes support Graviton2. Docker itself is able to support Graviton-based processors. And our own container services such as ECS, the Elastic Container Service, as well as EKS, which is more Kubernetes focused, both support Graviton2 and ARM. Also, popular container registries such as ECR and Docker Hub support multi-architecture images. So they're fully ready to be image repositories for your ARM images or your multi-architecture manifested images as well. And we also have support for some newer container technologies such as BottleRocket and Firecracker. So with all of that said, how do we go from developing an application to getting it deployed on AWS on Graviton2? And this is definitely where CircleCI can help. And Robert's going to help walk you through what CircleCI is doing to support your ability to build, test, and deliver ARM-based applications into AWS.
Great, thanks, Michael. So let's look at using AWS Graviton2 with CircleCI. First, a little bit of the background. The history is in 2018, AWS Graviton tips were launched. And in 2020, the next-gen Graviton2 processors delivered a major leap in performance. Some of the key technologies are that AWS custom-built ARM Neoverse 64-bit processors are available for high-performance microarchitectures for the server market. This lets developers run cloud-native apps securely, at scale, and with better price performance. And looking at AWS and CircleCI, CircleCI was the first managed service to offer CI/CD with ARM compute. And CircleCI ARM lets you build, test, and deploy apps for ARM without managing your own systems. And of course, with AWS, you have unlimited scaling. Let's look at some of the technical benefits. This can streamline your migration process. So to move to ARM with confidence, CircleCI offers these ARM-based compute as an option for running your CI/CD workloads. Keep in mind that migration to ARM and Graviton2 often requires code to be validated on ARM instances at every development stage. And so CircleCI can help because you can weave ARM instances into anywhere in your build pipeline. It also reduces switching costs. CircleCI customers can use a variety of compute types within the same pipeline. You can mix and match x86 and ARM instances as you need. For customers transitioning to Graviton2, this enables multi-architecture pipelines to simultaneously validate code for both ARM and x86-based environments. It's also a risk-free way to begin building and testing for Graviton2 without making a costly investment into new infrastructure. So advantages for startups and open source projects. CircleCI ARM Compute and AWS enables teams to scale fully managed workloads faster with a better price performance ratio. And for memory intensive workloads, Graviton2 instances are quickly becoming a go-to choice for many open source projects. So let's look at how do you actually use this in CircleCI. So one of the fundamental things about CircleCI is that we offer a variety of resource classes. And this basically gives you customizable compute. You can configure resources for each executor type. You can use different resource classes for each job in your workflow to optimize your pipeline. And this lets you get strategic with your usage of credits in our performance plan. So for example, you can see in our standard Linux instances, we have a variety of resource types, resource classes, from small all the way up to 2 extra large plus. So for example, some workloads might require very few resources, like say it's a quick upload or pushing up some files to a registry or repository. In that case, there's no reason to get a really powerful instance for that. You can just use a small and save your credits for something more important later. But other resources might require, other builds may require much more resources. It's like something like Bazel builds or linting thousands of files. In that case, you might want something that has a lot more power. So you can see in the little example below there, we have a test that branches off into 2 separate jobs. And that first one could be a medium size resource, and the lower one could be a small. So this lets you anywhere in your pipeline, pick and choose the right mix and match of executor type and performance. And looking at our ARM resource classes, we currently offer 2 resource classes. We have ARM Medium and ARM Large. Medium offers 2 vCPUs and 8 gigs of RAM, and it's available on our free performance, scale, and custom plans. And ARM Large has 4 vCPUs, 16 gigs of RAM, and it's available on our performance, scale, and custom plans only. So how do you actually use these in a typical configuration? Let's look at a standard Linux configuration. So on the right side, you see some YAML, which is a configuration document for CircleCI. And in this example, we see a workflow in a build that has 2 jobs, a medium and a large. And each of these jobs is simply printing out a little bit of information saying, hello, Linux. But you can see on the first one, we're using a medium resource class. And the second one, we're using a large resource class. So this is an example of showing you that you can mix and match the performance levels as you need to. But what does it look like to actually use ARM? Is this a big process? Is it something really difficult? Well, it's not. The only thing you need to do is change your resource class. In this case, you see it's arm.medium and arm.large to use ARM resource classes. And I'll also point out that your image needs to change too, obviously, because you want to run an ARM64 operating system image on your ARM hardware. So again, this supports ARM64 operating system images. And as before, the machine executor resources, each class is a dedicated virtual machine that's created specifically for your job. So that's really all that's required to change or to start utilizing an ARM configuration. Now let's take a quick look at a customer case study. We interviewed Culture Biosciences. Culture Biosciences considers themselves the AWS for bioprocessing. They say it makes it as easy to scale bioprocessing as it is to scale code. And their challenge was that previously they were building Docker images with virtualization, but the solution was no longer effective with processing time taking in excess of 6 hours. So AWS and CircleCI have a solution that's ARM Compute and Graviton2. The results were that they said it saved them headaches, and that's worth a lot, which of course is worth a lot. But more importantly, it reduces bugs, saving hours of developer time per week and tens of thousands of dollars a year. It eliminates bugs that impact the customer experience. And obviously, it's going to reduce your processing time. If you're not trying to cross-compile with virtualization, you're going to have much better processing time for those builds. So they considered the migration was painless. And they said, if you need to build Docker containers for ARM in the cloud, then it's a flawless, seamless solution. And that's pretty good praise. So how do you start learning about this? And how do you start using CircleCI? Well, if you go to CircleCI.com, you'll see that we have a large number of tutorials and example projects. We have companion guides that go along with some of those. You'll see that we've got things like Linux, iOS, Android, and Windows, but we also have sample projects for a wide variety of programming languages and application platforms, such as Python, Java, Node.js, Go, etc. So you can go there to get all kinds of examples for how you can use CircleCI. But more relevant to what we're talking about today, there's a blog post that CircleCI and AWS worked on together, and it's posted up at the AWS Partner Network blog. This post talks about building, testing, and deploying containerized application on AWS Graviton2 using CircleCI. And this is just a snippet of that blog post. It's actually a much lengthier article, and it goes into lots of details about configuration, how you set up CircleCI, how you use those ARM instances, and how do you actually deploy it to a Kubernetes cluster in AWS. So take a look at that blog post for more information. So let's recap some of the key benefits. Innovation and scale. So with CircleCI and AWS, we offer innovation and scale in that CircleCI delivers the first fully managed ARM-based CI/CD with Graviton2. And AWS brings unprecedented scale to the ARM developer community. On-demand ARM compute. Build, test, and deploy ARM-based apps without managing your own machines. This is a great way of getting your builds done without having to worry about investing in capital costs or the overhead of just managing your own machines. Next, price performance. You get up to 40% better price performance ratio using these ARM-based instances. It's a multi-architecture solution, so simultaneously validates code for both ARM and x86-based environments. Again, using our builds where you can mix and match those types of environments, it lets you solve for many cases where you might have to deploy to multiple platforms. It lets you do this all in one build process. And finally, it simplifies your decision-making. It reduces your barrier to entry for ARM-based compute. You can give it a try with very little investment. It's very easy to configure it, and you can start testing the waters with ARM. So that's basically it for CircleCI and AWS Graviton2. We'd love it if you'd get started. You can learn more by going to aws.amazon.com, EC2/Graviton to learn more about their ARM processors. And you can come over to CircleCI.com to learn more about our products, read our documentation, and see some example configs and tutorials. So that's basically it for today's webinar. Let's pause for a second and see if we have any questions. Okay, looks like we are all set. So thank you all for attending our webinar, and we hope you got to learn a little bit more about AWS Graviton2 and CircleCI, and we hope you'll take a look at our products and give them a try. Thanks a lot.